Welcome, pre-calculus students. 11.4 to 11.6, we're still keeping on. Today is our last lesson from 11.4 through 11.6, reviewing solving equations involving logarithms. So this is page 15, and on pages 15 and 16, there are, I think, 8 different equations. And first, I would start by looking them over and see what you notice. And then there are 3 different types basically. And I'm going to make 3 separate videos, one for each type so that they're shorter, so you can focus on what you maybe need the help with. Okay, so we are going to start with ones where the variable is an exponent. Okay, so that's what we're going to start with now. So you might have noticed that as you were looking. So there are 3 different types. Variable is an exponent, or we could say it's an exponential form. You could have it where you have a log of something equals a log of something. You could have it in a logarithmic form, right? Log on one side, number on the other side. Okay, so for each of these types, we're going to have different strategy. So for the first type, which is what we're going to start with, we're going to isolate the base with the variable, and then we're going to take the log or the natural log of both sides. Okay, if we have log base b of m equals log base b of n, right? They both have the same log base b on both sides. We're going to set the m equal to the n and then solve. Okay, you may need to use the log properties to condense each side to get it into this form. Right? Or we could have a log on one side and a number on the other side, so that logarithmic form. And what we would do there is rewrite it in exponential form. Again, you may need to use log properties to condense. Okay, so these letters here represent the letters that correspond to each type. Okay, so this video is going to cover E, F, G, and H. So on the other side. Okay, so our idea is that we're going to isolate the base that has the variable on it, and then we're going to take the log or natural log of both sides. So in part E, right, the 5 has the 4x, the exponent on the base. And so what we're going to do is we're going to take the log or the natural log of both sides. Now you could take the straight up log, which would be log base 10, or if you choose, you could take the log base 5 of both sides, because the base on that exponent is 5. Whatever you choose, you have to do it to both sides. Same thing to both sides. So I chose log base 5 of 5 because when we're doing this, we're thinking 5 to what power is 5 to the 4x power, right? So if we write that out, 5 to what power is 5 to the 4x power? It's just 4x. Okay, so doing that kind of eliminates the need for having to divide by a log. Okay, now on the other side, when I have the log base 5 of 73, I am just going to put that into my calculator. Okay, so I'm just going to hit log base 5 of 73, hit Control Enter, and I get 2.67. Usually I want to go out hundredth or thousandth on these. Okay, and then you just need to divide by 4. And so I'm getting about 0.67 for my answer. Just can't see that very well. Okay, if you don't have a calculator that can do the log of any base, but could only do like base 10 or base 5, or I'm sorry, base 10 or like in E, when you're at this point, you could have just done log base 10 of both sides. You could have done log base 73 of both sides, and then that just would have been 1, and then you would have gone from there. If you do it this way, then we would have to bring the 4x in front. We would divide off the log of 5. So I'd have 4x equals whatever I get when I put that in. So log, and I have to bump over for the 73, and then bump out, and then log, bump over, and then I get the 2.67. Okay, and then I still end up dividing by the 4. Okay, so you see we get the same thing either way. Do what makes the most sense for you. Okay, so now on this one, I have exponents that are variables, and I have 2 different bases. I would just choose one of the bases and take the log base that of both sides. So I would either do log base 2 of both sides or log base 5 of both sides. It really makes no difference. Or you could do log base 10 of both sides or ln of both sides. I'm just going to pick 2. Again, there's no benefit of doing one over the other. Okay, so I'm going to do log base 2 of both sides because doing that over here just leaves me with x minus 1, right? 2 to what power is 2 to the x minus 1 power. Okay, over here, I'm going to have to bop this x minus 2 in front, and it's times log base 2 of 5. And I am going to need to figure out what that is equal to. Okay, so again, I'm going to use my calculator, log base 2 of 5, and that gives me 2.32. And then I do need to distribute that. So I notice I put that x minus 2 in parentheses when I brought it down in front. I do need that in parentheses because I have to distribute it. Okay, but now it's just a matter of solving a linear equation. So I'm going to, I think, subtract this 1x over here. I'm going to add this 4.64 to get that x. I'm going to get the x's over here on the right just because I don't know, I like a positive. And then here, this would be 3.64, and then I would just divide by the 1.32. So let's see, what do I get? 3.64 divided by 1.32. So I get x is 2.76 for my final answer. Okay. All right, so let's take a look at this next one. 18 equals e to the 3x. Okay, remember when the base is e, that's like a natural log, right? It's easiest to take the natural log because natural log is when the base is e. So I have the natural log of 18 equals the natural log of e to the 3x. So this we're thinking e to what power is e to the 3x? Well, just 3x. And natural log is here above our e to the x key. So I can just hit natural log of 18 and get 2.89 and then divide by 3. So I'm getting about 0.96 for my answer. Okay, the last one we have is an inequality. Okay, so remember we said we wanted to isolate whatever has the variable for the power before we take the log or the natural log. So here, I cannot just take the natural log of both sides, and a lot of times people want to do this, and then they want to say this is like 25x times natural log, 25x, and natural log of e, so it's just 25x. But that's not how it works. Like if you take the natural log of both sides, if you take the natural log of 25e to the x, that's the natural log of a product, and you would have to split that into like ln 25 plus ln e to the x. It's different. Okay, so what I'm going to do first is just divide by the 25. Now, some of you also might be noticing, oh, hey, that's an inequality. Really is going to work the same way. Okay, here I'm going to take the natural log of both sides. Natural log of e to any power is just that power. And then I'm just going to plunk that ln into natural log of 4 into my calculator. So x is less than 1.39. Now, there are some times where like the inequality might change. And when that happens, like to know if that happens, what you really kind of want to do is almost graph both sides of the equation just to double check. It does sometimes switch. So if I were to enter e to the x, and then if I hit tab and then I enter just 4, so I'm kind of like graphing both sides of this, and I want to know for what values is this curve less than 4, which would be start. Here's the 1.39, and it's every value to the left of that, so it's less than. Sometimes you might notice that it switches, sort of like when you divide by a negative. So just something to keep an eye out for. All right, I am going to post videos on the other examples separately. Take care, everybody.